Hi everybody, welcome to my kitchen. We're going to do physics from my kitchen today instead of the lab I had planned for in class. We'll see how this goes and maybe we'll do some regular kitchen physics. Today we're going to build a cloud chamber and look at particle tracks left behind as particles pass through and ionize some supersaturated alcohol vapor. So the way we're going to make this supersaturated alcohol vapor is to set up a big temperature difference. So we'll have a very cold bottom and a pretty warm top of this closed airtight tank. And then there'll be a pad saturated with rubbing alcohol at the top of the tank, which alcohol then evaporating into the air in the tank creates the conditions for the track formation. So much of what we're using today is pretty accessible, and you could definitely do this at home. I'll give you some links to information about where to get materials and how to put this together if you're interested in seeing it for yourself. It's really kind of magical to see these tracks. The only thing you're going to have a hard time right now getting is the isopropyl alcohol, the rubbing alcohol. I happened to have this bottle left over, and it's definitely a pre-COVID-19 situation to have that rubbing alcohol. But maybe you can find something on Amazon. So in any case, we're interested in safety. We're going to be working with the rubbing alcohol and dry ice. So I've got my safety glasses on that I managed to grab from the classroom before the building got shut down. And whenever I'm working with the dry ice, I'm going to use some mitts, some oven mitts. So the first thing is that we're going to make a bed of dry ice. And I usually prefer to have blocks of dry ice, slabs of dry ice. I have the dry ice, usually the slabs of dry ice are on top of some kind of insulating material. My packing peanuts are now kind of mixing with the dry ice chunks in a way that I'm not sure it's going to be good, but I'm trying to create a layer of dry ice. And then on top of that dry ice, we're going to put a metal plate. So this is a piece of aluminum. It's probably 1/4 inch thick. It's been anodized on top. The important thing is that you have something that's heat conductive and something that's relatively dark on top helps you see the particle tracks once you set it up. And it becomes loud. Smoke that out. That is very disturbing to my lab assistants. The guinea pig cage is in our living room behind the camera, and they're very disturbed by this scientific experiment in the kitchen. Okay, so we've got our dry ice with some insulation, and then on top of the dry ice is a metal plate. If you're doing this at home, you can use a cookie sheet or a pan, like one of those. Okay, so I'm finished touching the dry ice for now, so I can take my gloves off. And the next thing we're going to do is saturate a pad for the alcohol on what will be the top of our tank. So I have an old towel that I cut up and glued onto the bottom. You can use felt. I think anything that's absorbent is fine. And we want the pad to be soaked, but not really dripping. I'm sure there's problems with the way I'm handling this chemical, but so I have doused the pad, and then I'm tilting it to see if it's saturated. It looks good. I've got a couple of dry spots though, so I don't want any dry spots. This time, there are probably people who are really upset that I'm using rubbing alcohol for a science experiment instead of using it to disinfect, but okay, so I've got a soaked pad of alcohol on top, or what will be the top. And the next thing I need to do is provide a way for an airtight seal. So before I started recording, I rolled out some snakes of Play-Doh. I stole some of my son's Play-Doh. And I'm going to use the Play-Doh as something like plumber's putty to make an airtight seal between the rim of the tank and the aluminum plate below. I found this part to be the trickiest, getting the seal. failures of cloud chambers, they are usually because I have a spot where air is coming into the tank. Then I'm going to flip it upside down, trying to keep the Play-Doh in place. Not bad. And then I'm going to mash it down to make that airtight seal. Oh, nope, I missed a bit right here. So like I said, this is probably the trickiest part. Well, aside from finding the rubbing alcohol at this time in our lives, this is the tricky part. So I'm going to mash it down to make that seal. And then I want a temperature difference. So on top of the tank, I'm going to put a heating pad. It's like a sore muscle heating pad. Try to make it so that you can still see what's going on in the tank. And then I found adding a weight on top tends to help keep the seal. So now we're going to need to wait. We need to wait for this alcohol cloud thing to form on the inside of the tank. And while we wait, I think I will add some more putty around the edges just to be super sure that I've got this sealed up. It takes about 10 minutes to get the conditions needed to see the particle tracks. So I'll see you back in about 10 minutes. Okay, it's been about 10 minutes and I have a very cold bottom and a warm top and alcohol vapor in a supersaturated state inside. I'm going to have to move now, I think, into the bathroom because I can't control the light enough in my kitchen and family room. But the next step is to try to see the particle tracks. And the way we'll do that is to shine a light. So I've got some LED strip lights, and we'll be shining the light down onto the bottom, to that bottom plate, and we'll be looking for something that looks a lot like contrails. I actually just saw a nice big fat track. Ooh, and another one. So it's happening right now. These are happening all the time. Particles are all around us all the time. We're just trying to see evidence of them. So we'll move into a darker room and we'll try to catch some of these tracks on video. Well, my dears, my life gets weirder and weirder every day. Welcome to my bathroom. As you can see, the setup is the same. I have the same cold bottom and warm top, and the lights now are illuminating, trying to illuminate the bottom plate, so the cold plate. And I've turned the video to higher resolution. I recognize that there is a lot of weird glare. If you look closely though, you can see what looks kind of like snow falling. Kind of mist or snow. It's easiest to see just a little bit above the black plate. I think I'll try moving this light over to here. It's real hard to get the lighting conditions just right and get the camera in a position where it can see through this plastic tank. Okay, so I can, as I was saying, let's try to put just a little bit sideways here. As I was saying, we are looking across the black surface of the metal plate. It looks a bit like a mist falling onto the black plate. And then through the mist, every few moments, there's something that looks like a faint contrail. So the white path left behind by airplanes. I'm seeing a lot of long straight lines in the right side of the screen. Ooh, I saw a super long line just now across the bottom. I see some shorter, thicker lines. And again, we're looking through this kind of falling snow or falling mist. we're looking for the paths that become apparent through the mist as the mist falls. So you basically just have to be patient and watch. There was a couple. So some of the tracks are very long and straight. Some are short and thick. Some are fainter than others. These tracks are three-dimensional. They're happening through the whole of this mist. So I don't think we see the tracks very well that aren't parallel to the plate. If I had a big enough magnet, we could make them all parallel to the plate. But that is beyond my kitchen technology. I'm going to shift this over a little bit and see if we can get, there's a better perspective. So again, we're looking through this mist and we're looking for these little lines. Some of them almost look like dots or blobs. Some of them are longer and straighter. They happen pretty fast. And as soon as you see the path, the ionized particles, or I guess it's not, there was a Z in the bottom. So some are straight, some are zigzaggy, some are swirly. As soon as the path becomes apparent, however, this mist is falling, so essentially the cloud is pulled down to the surface of the plate by gravity. So even if a path is very straight at first, as the cloud falls, it becomes a little bit less straight. It's mesmerizing. All right, well, there you have it. You've been doing physics in the kitchen and physics in the bathroom. It turns out an interior windowless bathroom is the perfect place to use a cloud chamber. I hope you were able to see some of those tracks. I will also link a video that shows a professional cloud chamber with great photography and some slow motion, and it will be even easier to see the tracks. What I could see with my eyes in real life was much clearer than what I was able to catch with the video. So if you have any rubbing alcohol and an empty fish tank, I highly recommend trying this on your own. It is amazing to see in real life.